here's problem 2, parts A, B, and C. So for the region bounded by the functions f of x equals the square root of x, which looks like this, g of x equals 6 minus x, which looks like that, and the y-axis, which is the line x equal to 0, we want to find the area of this region. So to find the area, I'm going to be thinking about a vertical strip. Basically, I'm adding up all the areas of the rectangle. So the area of my strip or my rectangle is just the top minus the bottom, that's the height. Sorry, my top function is g of x, not f of x. But then it's your height times your base, and your base is your delta x, or your dx. So then the total volume, area, the total area is the integral, right? We want to think about how much area you get when you add up all the strips from the leftmost strip all the way to the rightmost strip. Meaning we need to figure out where these functions intersect. So limits of integration we'll figure out in a second, but it's going to be g of x, which is 6 minus x. Come on. Minus f of x, which is the square root of x, or x to the 1/2 dx. And my limits of integration, well, we know the leftmost limit, right? The leftmost rectangle is at x equal to 0. The rightmost rectangle is at x equal to whatever this point is here. So you can set 6 minus x equal to the square root of x and try and solve it that way. But the easier way is try and guess like a thing that makes sense. Like, is it going to be 1? No, because the square root of 1 is 1, and 6 minus 1 is 5. They're not equal. Is it, well, let's say I don't want to try 2 or 3 because those are hard to take square roots of, but if I try 4, square root of 4 is 2, 6 minus 4 is also 2. So this point here is the point 4 comma 2, which means my upper limit of integration is 4. The rest of this is doing the integral. It's kind of a pain, but it's not too terrible. You get 6x minus x squared over 2 minus, let's see, x to the 3/2 divided by 3/2 is x to the 3/2 times 2/3 from 0 to 4. We're going to plug in 4. 6 times 4 is 24. 4 squared is 16 divided by 2 is 8. And 4 to the 3/2 is the square root of 4, which is 2, cubed, which is 8, and then 2/3 times that, so minus 2/3 times 8. And then minus, when you plug in 0, you get 0 minus 0 minus 0. But be careful with the zeros, right? You don't always get all zeros when you plug in 0. So this ends up being 24 minus 8 is 16, and 2/3 times 8 is 16/3. 16 is 48/3. Minus 16/3, you get 32/3. Okay, let's look at part B. Find the volume of the solid obtained by revolving the region or rotating the region about the x-axis. So again, here's our same region, and now I'm using a vertical strip because I'm rotating it around the x-axis, and your strip always has to be perpendicular to the axis of rotation. So my strip is perpendicular to the axis of rotation, and since my region is not flush with the axis of rotation, I have to use the washer method. So the washer method tells me that my volume is going to be pi times the integral of your big radius squared minus your little radius squared dx. It's still the same limits of integration, right? Because this region that I'm rotating around that way is still going from x equals 0 to x equals 4. My big radius is the function that's further away from the axis of rotation, which is going to be 6 minus x. The smaller radius is the function that's closer to the axis of rotation, which is the square root of x. The rest is doing the integral. So let's see, it's a kind of a pain in the butt. And I think I might have forgotten a pi in my solutions. See, my solutions are right here. Did I forget a pi in them? Nope, I didn't. That's good. You don't want to forget the pi. So, multiply this out. You get 36 minus 12x is where we get the 12, plus x squared, and the minus square root of x squared is minus x dx. I'm going to simplify this just a tiny bit. It's pi times the integral from 0 to 4 of x squared minus 13x plus 36. Anti-differentiate. You get x cubed over 3 minus 13x squared over 2 plus 36x. That seems terrible, from 0 to 4, Plugging in the 4, I'm going to get 4 cubed, so 64 over 3. And then 4 squared is 16. 16 divided by 2 is 8. And then 8 times 13 is 80 plus 24, which is 104. And then 36 times 4 is 144. And then plugging in the zeros will give us 0. So we end up with 64 over 3 plus, let's see, well, minus 104 plus 144 is plus 40. I'm going to write 40 as 120 over 3. And I lost my pi. It's no good. Yesterday was pi day. You don't want to lose the pi. You make sure, right, you can't just write the pi at the end. You need to write the pi in each step. So I end up with 64 plus 120 is 184 pi over 3. Okay, finally, the last question is to set up the volume for revolving around the y-axis. So it's going to be the same region. Let's see, let me go to the other side here. Same region, but now I'm revolving around the y-axis. And the issue with that is that we have to do things in terms of y instead of in terms of x. Meaning I have to draw horizontal strips instead of vertical strips. So here's my same region. And now I need to draw horizontal strips. Meaning my functions need to be functions of y. And also, if you look at this region, up above y equal to 2, your radius is going to be this function. But below y equal to 2, your radius is going to be this function. So we actually have to do 2 intervals. So the volume here is going to equal, now luckily we do get to use the disk method instead of the washer method because our region is flush with the axis of rotation. We do need to solve these, so this y equal to 6 minus x becomes, if I solve for x, if I add x and subtract y, it becomes x equal to 6 minus y. And this f of x, this y equal to the square root of x, if I square both sides, it becomes x equal to y squared. Okay, so the volume of this part here, if you revolve this around, right, revolving it around, you're going to get pi times the integral from 0 to 2 of your radius, which is y squared, squared, dy. So that's the volume of this part. So like, right, you can think of it as like looking like that. And then for the next part, so we have to add it on. It's going to be pi times the integral from y equals 2 to y equals 6 of my radius, which is 6 minus y squared dy. And that would be the answer to part C, which is just to set up the integral for the volume around the y-axis. Not that it really matters, but your picture, right, it would kind of look like this. It would be like, well, that's, I mean, kind of like that. Kind of looks like that. And then the top part would be like that. That's kind of, I mean, not the best picture, but anyway, that's how those problems work.